Hey, this is Brian.
And Shelby.
And you're listening to the Hyperspace
PodBlast. Aren't you a little short for a podcast?
Huh?
Hey, peoples, how's it going out there and stuff?
Right on schedule, Brian.
Yep, nailed it.
So we have a special guest with us today. Welcome to Hyperspace PodBlast number 14. Wow.
Is it 14?
Yes,
Wow.
It is. So we have a guest with us today. This is Anne, and Anne is a petrophysicist. So hello, Anne, and what is a petrophysicist? What do you do?
Well, hello. It's really nice to be here. So what does a petrophysicist do is a question that I get asked a lot, along with what? So, if I'm giving a very vague general explanation, I say it's a kind of geologist, except I do a lot of coloring. If I'm getting a slightly more technical explanation, I say I am a geologist, but many petrophysicists are also engineers, and I specialize in calculating the properties of fluids and rocks. And for me, what that involves right now is calculating the differences in fluids, which is hydrocarbons versus water or natural gas. So yeah, it's fun. It's actually significantly less boring than I'm making it sound right now, and there is a lot of coloring. So I get all sorts of different measurements from somebody drills a well, and I sort of amalgamate them all into an interpretation, and I do a lot of math to figure it out, but then I have to communicate it to people who don't know what I'm talking about. So I am not kidding. I do color it. I can color code things that make sense to people, and they don't need to know all of the things that I know or my friends who are also petrophysicists know. We can just make it easy for you to understand, which I think is a critical component of science too. Communication. Like, you don't have to be a snob. You figured it out. Great job. Tell other people.
Yeah, so Anne does something that's closely related to what I do. So that's how we know each other. But one of the main reasons that we wanted to bring her onto the podcast was because of all of the talk about the different geologic properties of Star Wars and the different worlds in Star Wars, and specifically a lot of things that were talked about in relation to The Last Jedi trailer and Crait. So what is the deal with Crait, Anne? Because we see in the trailer...
Yeah, all the red dust. At first, people were like, why do their engines put out that red stuff? But, yeah, I was adamant that it's those little dangly dudes that are kicking up the dirt.
That's the technical term, dangly dudes.
Yeah, that's the official...
sticky outy bits is what I use as a scientist.
It's in the Star Wars data bank.
It's canon.
It's
canon.
Yeah, true. Yeah, that's the
canon.
The official canon sound effect.
That's the next scene.
So yeah, anyway, it's the dangly dudes are kicking up the dust of Crait, which it looks white, but then it becomes red. So
yes,
right, with Ryan Johnson even saying that the white crust is salt.
Ooh, yes, perfect.
So that's why I was like, ooh, depositional environment. I talked about this stuff in my very basic engineer geology classes. So, Anne, tell me what's going on.
You've come to the right place for some wild BSing. All right. So, the first thing to notice is that looks really flat where they are. It looks a bit like, those vistas when you look out across a flat desert. And those things tend to happen when you have a dried lake bed, or also known as a playa, or an ephemeral lake where you have seasonal flooding or stuff like that, and then that water all evaporates and leaves behind whatever was dissolved in it. And then in this case, it looks like you have a dissolved layer on top of that white stuff that is precipitated, the salts, and then underneath that, some really fine red stuff. Now that a really fine sediment, clay sized or smaller, would make, if it was kicked up, it would make dust clouds like that. The odd parts are the colors. So if you dive in a little bit and you look at what they were mining for, it actually starts to make perfect sense. So those red minerals, there aren't a lot of things on Earth that make bright red colors. So that's kind of a starting point to kick off. Obviously, the Star Wars universe is going to have all sorts of odd minerals and made up stuff.
Yeah, they can do whatever they want. So
right, they can do whatever they want. It's fiction. But on the other hand, it's kind of fun when they ground it in reality too.
Yeah, I mean, most stuff has some realistic context to it anyway. I mean, because
absolutely, because
nothing's completely made up,
Also, they know that their world is going to be scrutinized by nerds like me, so
Touché.
You should probably cover your bases, amongst other things you cover. So there are a limited number of things that'll make a bright red color.
Iron.
Yes, iron will, but iron tends to make, it makes different shades of red, but the most traditional red color you think of when you think of iron is rusty colored. So you get iron oxides. You also get like weird rare earth minerals, which are funner because they're rare, right? Like vanadium. Another earth mineral that you would get would be cinnabar, which, by the way, one of the rules of geology, one of the nicknames of geologists, for context, is rock lickers, right? And there's joking, and there are legitimate scientific tests that you can do by licking rocks. But geologists also know that you never lick a red rock.
Oh.
Because red things tend to be poisonous.
Okay.
Like cinnabar. You'll always see advertisements for like things carved of cinnabar. It's like a decorative plate. I'm like, that is decorative. Do not eat off of the cinnabar plate because you will die.
It sounds so good though. Like I can't stop thinking of cinnabon.
Like cinnamon, cinnabar. Like what could possibly go wrong?
Yeah,
Death.
Exactly.
Death is what could possibly go wrong.
I shouldn't open a cinnabar donut shop.
Because of your arsenic poisoning. Oh. Do not open a cinnabar bakery.
Okay.
You might be fine. You won't get a lot of repeat customers.
All right.
Yeah, on the surface of it, genius. So when a lot of geologists watched that trailer, we went, ooh. So that top thing, so usually also if you have a dry lake bed that sediments are washing down into, then you would expect it all to kind of be the same color. So a change in color also requires a bit of a change in geologic paradigms, right? So you've had some sort of a change. Some sediments are coming from somewhere else, or you always have those things in the water and the dirts and things don't dissolve so much as they are floating in it. They're carried along by it, but they never dissolve in the water and then they settle out. And what's left dissolved in the water is the stuff that causes the white crust.
Okay, so almost like a silt-ish kind of
thing. So
thing.
A silt would be a particle versus a dissolved thing.
Right.
So you can dissolve salt in water, right? But if you put dirt into water, it'll just sort of float and settle out. Same idea. So it's possible that this is caused by whatever the red stuff is, doesn't dissolve in the water that's washing it down out of the surrounding mountains. And so it's depositing there by being washed down, but it never dissolves. There are other salts that are dissolved in the water, and when everything evaporates, the white crust is what's left behind on the top last. So that's my current running hypothesis.
I like it.
Yeah,
and then
that makes sense too. That like it doesn't look like the dangly dews or whatever I call them earlier.
No,
I don't remember. They're not digging deep. It's just like scraping.
Just
so whatever that
level.
White is really really thin.
Yeah. And you can think about in terms of even if you took a whole bunch of salt water and dissolved it. If you go into the ocean, which is fairly saline, and it dissolves, you're gonna get a very light crust on you. Right? Not enough to really leave a color, just enough to make you feel slightly gritty, right?
Right. Yeah.
And so if you super concentrate things, there's still only in a little bit. And those are, if you think about the scale of one of those ships and they're digging down a couple of inches, you have to have a significant amount of water to do that. And so desert lakes, playas, tend to have thin crusts of stuff on top anyway. And in areas around, like say the Mojave Desert in California, you get a lot of those ephemeral lakes that are seasonal. Stuff washes down in the winter when everything is wet, and then everything dries out in the summer. And then the winds come along and whip everything up into the air. And you can get lots of weird airborne pollutants, really, that can go high up into the atmosphere, travel around. They can be significant breathing hazards, actually. And so that's kind of an interesting element to me. I'm like, are they kicking up toxic clouds? Because I would not want to breathe that.
Oh, you think it could be like a military tactic?
I'm curious. Also, it's pretty opaque, right? If you're
it could be like a smokescreen.
Exactly. Did I mention wild speculation? So those might be the first ships coming in, but who's behind them?
True. Also, it could mess up their targeting, I suppose.
Yeah.
Like you just the computer device just sees a big blob coming toward it.
Or what kind of scanning mechanism are you using, right? Like what's your...
Is it looking for...
If it has metal in it.
Yeah, exactly.
Right, and you just kicked up a bunch of heavy metal dust?
Yeah,
it could mess up all of your
smoke screen for visual, but also a whole bunch of communications and a whole bunch of other stuff. Yeah.
I like
it's an interesting hypothesis. We'll see if they go anywhere with it or if it's just pretty.
Yeah, exactly.
But I can come up with all sorts of science reasons why you would want to do that if you were a pilot.
Good reason for that dangly thing to be there. You know what I mean?
Why is
aside from
just
either
cool.
it's either
it just looks
dun.
It's completely aesthetic, or there is some more.
Yeah, and they're pretty dang good pilots. Why are they bouncing off of the ground?
Like why? Like if they're great pilots, why would they end up accidentally knocking
that much sediment loose?
Yeah,
yeah.
It has to be intentional, in my opinion.
I'm also curious about exactly what kind of mineral that is. I really do want to know.
Right? Yeah, I know.
And also if it's precious, like
yes, like are they defending a resource, or does is just happened where the battle is. Because, I mean, we've also found out in the last couple of episodes that there are a lot of strange and interesting and new things that went into the Death Stars. So they were hoarding a lot of elements and minerals and stuff like that, finding strange things, kyber crystals, and getting the whole galaxies locking down certain resources.
Yeah, true.
Is this a defense of a resource that they needed for that construction?
Yeah.
Or is this just incidental because it looks cool?
I heard a lot of, like, someone had a recent speculation about kyber crystals and it being, you know, the crystalline ordered structure of midichlorians within a kyber crystal. A living organism
And
becoming a
just
crystal.
Echoing in it's diatomite. I mean, there are certainly living organisms that make minerals that are organically formed. I mean, anything that makes a shell, right? Most shells are made of calcium carbonate, which is for sure a mineral and can precipitate out of water just as well. But you get interesting structures when the mineral structure isn't different. The forms made by the mineral structure are different. You don't necessarily get like a crystal growing. You get a shell, right? Even though it's made of the same stuff. On a microscopic, atomic scale, molecular, it's the same mineral, but it's arranged a bit differently. Think of it as like microsculpting rather than a difference in the molecules. So that's an interesting hypothesis, except kyber crystals, when we've seen them depicted, seem to be crystalline.
Yeah, quite.
Yeah.
And I wonder how, if we'll ever see specific, you know, they're mining for kyber crystals, and they talk about how Sith are actually manipulating the kyber crystals, and that's why they're red, is because they're, like, bleeding. But I also wonder, will they ever do, like, lab-created kyber crystals?
Yeah, that's actually what they did, like, in the old EU. That's where Sith got their crystals from, was they were, like, synthetic, rather than... But then, you know, they dropped all these different bombs and kind of got rid of it.
Whoops. It's an interesting thing when you get into stuff like synthetic crystals. I mean, in the most famous example of synthetic crystals is people have been arguments about diamonds versus synthetic diamonds, if they're naturally occurring versus synthetic diamonds. And those require very precise pressure and temperature situations. But if you're controlling it, what you actually usually end up is a very pure, cool specimen. I'm fine with synthetic minerals, actually, as precious gemstones. Natural ones tend to have all sorts of unpredictable, you want to call them impurities?
Yeah.
But it's really the stuff that makes flaws or impurities, things that make it interesting.
Right, exactly.
Which sometimes people think about flaws as what, like, what
gives it character.
What gives it character, or makes someone human, like your own human flaws.
Absolutely. So when you make that a parallel...
Yeah. Because I'm thinking
should we homogenize humanity and everybody else? Or should we allow people to have character?
Oh.
Balance, if you will.
Oh! Love it.
Oh,
I love it. But if it's so pure as a crystal, if it's lab created, and then a Sith was using it,
right. Now
does that give you such, like, incredible power because it's pure?
Does it actually give you power, or does it detract from it because it has no character of its own?
That's true.
Yeah, and you didn't, you know, go through the whole process of finding it. Like, that's, you know, part of even in
the quest.
Yeah, it's been in the expanded stuff gone into a lot, but even in the original trilogy, you know, Vader says, "I see you've constructed your own lightsaber. You know, your training is complete," or whatever. Paraphrasing, obviously, but so that it's, I don't know, like, making it just seems like cheating, kind of
a little bit.
It's like the kid.
Let's skip all of our own internal character development and be like, well, hey, if you're evil, why not? Right?
Yeah.
Introspection's the enemy of being evil.
Yeah, it's the kid who I'm going to use a hockey reference. It's the kid who shows up to the pickup game with, like, pro level gear on, and, like, the rest of us don't even wear shoulder pads.
Some of us who game don't use cheat codes.
Yeah, exactly.
It's the cheat code of Star Wars.
Right? Yeah, there you go.
Crystal. Yeah, no, I can get behind that.
So I kind of want to shift here. If we're talking, you know, we're talking about Sith, we're talking about all these different impurities, but what if we're going to, say, Mustafar?
Speaking of Sith.
We're going to Mustafar, this, you know, fiery planet in the Outer Rim. Why would you mine lava?
Or a miner? Do you even mine lava?
Do you mine lava?
It looks
sort
like
of scoop it?
Yeah, because when they're on in episode 3, while they're having their battle, you see all those little droids come, like, with a big, like, I don't know, bucket, and they're like,
yep, that
I'm gonna
sounds
grab
about
me
right.
some lava, and I don't know what I'm gonna do with it, but I got it.
First, I got some lava. It's the opposite of a snowball.
Yeah,
right? Yeah. So, I mean, the first bit is, like, they actually did a really nice setup that it says we've got an erratic orbit between two gas giants. So, if you want to have a stable planet, you need to have a stable orbit, right? And so, one of the reasons you get erratically shaped moons, like around Jupiter, Jupiter and stuff like that, is if you have weird gravitational pulls from different directions when something is moving, it'll warp the surface of a thing. You have to have a body needs to have enough gravity of its own to become spherical, and then it needs to be in stable orbit around something to not get warped more to develop like a proper structure. So if you put something in orbit between two large gas giants with a large gravitational pull of its own, with an erratic orbit, it's going to the crust of it is going to never be able to solidify because you're pushing and pulling and constantly cracking it. I mean, here on the Earth, we have tides, right? Just from the moon, which is tiny, and it's pushing and pulling our water significantly. And we actually have earth tides. They're just not detectable to people. But if you put a seismograph and some stress meters underground, you can measure the earth tides in the ground itself from the moon, which is cool. And so have things significantly larger than the moon and have it moving around erratically, and you're going to completely mess up. Imagine how much volcanism we had if we warped our crust that much. So the whole lava surface thing, I'm on board. So yeah, if you were mining lava and you're talking about a liquid,
right?
So whatever's melted is melted, and that's what you're after. Yeah, buckets are the way to go.
Yeah.
You just need to have a bucket with a higher melting temperature than the stuff you're putting in the bucket.
What's the melting point of dunium?
5. Please don't ask me about units.
Exactly. I was going to say, what? Are we in ranking?
You just need buckets that are 6.
There you go.
Science.
I guess it's sort of like foregoing the process of like smelting, I guess. It's like already done for you.
Well, if you kept it liquid, you could make an approximation there. If you did your refining on the planet, a lot of magmas or lavas, I guess it's lava because it's on the surface where they're going, they still are all mixed together and commingled. You would need to heat it to different temperatures to properly smelt and get things to separate out. Yeah, whatever forms a crust first, knock it off and you're good. If you cooled it slowly enough, you could get differentiation of the different things in it. If you took it off planet or cooled it immediately, it would just sort of chunk up and make a whatever. Actually, if you cool it slowly enough, you get obsidian and volcanic glasses of different kinds, which could still be handy, depending on how much you want to sort of give people glass cuts. But yeah, I mean, if you're wanting to also deal with things like transportation, as long as you're fine with the dealing with temperatures is the hard part. Dealing with a liquid can be significantly easier than dealing with a solid. You don't have to worry about the shape of the container you're putting it in.
True.
You just pour it all into a tank, and there you go.
You just keep it heated during transfer, so it doesn't.
Don't let it cool in there and heat it again when you get to your refinery. Yeah, depending.
Just make your vessel like have a hinge on it, so you can just dump out the whatever becomes solid once you get it to where you're going. Interesting.
Gives you options. Yeah. Let's say, as long as you have a means of not dying by lava.
Yeah.
Anakin.
Yeah. At least it wasn't sand.
I actually mentioned it whenever we were talking about melting points, but what about dunium? What would that... some sort of metal, what would that, I don't know, relate to in our galaxy or our world? What kind of metal would dunium be? What kind of commodity?
Yeah, what would be so precious that you would use for, like, store for such a large scale thing? I mean, would it wouldn't be something as simple as steel, I would.
No, I think we're getting out of elements and into weird minerals and into weird alloys. So when you think about in terms of a kind of a logical extension, you go through Stone Age, you go through Bronze Age, you go through Iron Age. I mean, now we're in steel, and we're getting trickier and trickier with metals. And what are spaceships made of? I don't know. Magic and unicorns and hope
and rainbows.
It turns out spaceships are also built on hope. Oh, full circle. So
perfect.
Thank you. So when we get into the next logical extension of we're out in space, we're doing more and more complicated things. We have to have those big leaps in technologies, and a lot of times those are accompanied by leaps in our materials. And I kind of like the idea of something we don't know about yet. We haven't even invented it. Or we can do it because scientists and metallurgists are always inventing new materials, but a lot of times on Earth we're restricted by what's available. Rare earth minerals are called rare for a reason. It's because they're really hard to get. And you find an entire planet made of something that you can use to make a bizarre, strange, extra strong, lightweight alloy. You're in business. You're going to want to get a monopoly on that right away. And so that's kind of what I'm imagining for Dunium. I mean, for starship construction, you want something that's really durable, right? But lightweight.
Right, yeah. You don't want to have to like thrust out the wazoo to move the thing.
Exactly. Especially if you're escaping a gravitational orbit in space, like whatever.
Yeah.
But
BFD.
right. But if you are moving around inhabited planets and down to them, and a lot of times in Star Wars we see ships, moving off and on planets. Not so much Death Stars, they don't tend to land, so maybe it's not as applicable. So it's supposed to shield the hypermatter reactor core and focusing dish. So I don't know what properties those would take. So maybe it's a hydrated mineral. Water tends to block neutrons, so sure, why not? Let's speculate. Did I mention this is the right place for rampant BS? Yes. So sounds important. I said neutrons. So yeah, I mean, you can speculate that there's going to be a lot of weird stuff coming off of that hypermatter reactor core. I mean, whatever that is, you're having lots of reactions in it.
Yeah, hyper ones.
They're very excited. Yeah. And that anytime humanity's gotten into a high level of physics like that, there tend to be a lot of particles that are put off that are not so necessarily good for the human body. So shielding that seems critical if you want more than one Death Star crew. So
yeah, it always kind of felt weird to me when like you see the Death Star fire and those guys are just kind of like standing next to it. They're like in that big tunnel and they're like, oh look, there goes the laser. Like I just feel like they should have been oblivious. Like like given my own personal options, I would not stand that close to the death laser. Right. That
Gentlemen,
just seems like
maybe move behind the protective shielding. The sort of open air aspect to the giant makes me a little nervous as a scientist. Yeah. I'm the one with goggles on.
I need some PP&E.
Like maybe the armor all had a little bit of dunium in it.
Oh dang, maybe.
Did I mention blatant speculation? That would actually not be a bad plan. It's basically everybody's built-in safety gear, right? But on the other hand, if it's as rare as it is, then I mean, obviously
not.
Are they
gonna
That's
really
like
be able to outfit how many people with that?
Yeah.
Like
most of my clothes don't have platinum embedded in them. So yeah, I mean, I can speculate a lot about the dunium.
Well, let's move on from dunium to thorolide. I think that's how it's pronounced.
Sure.
So what do you think?
I'm on board with thorolide.
Thorolide would be. It's less rare, I think. More of like a, I don't know, titanium maybe, or would that be more of a dunium type comparison?
So I like the ability element of thorolide. So it mentions here in our reference notes that it was highly difficult to mine due to its tendency to decompose itself into smaller elements. So there are like lots of Earth parallels for that. So one of the, actually, not to return to playas from the first minerals, but there are a lot of elements that we mine and that we can use that are things that evaporites, where if they come into contact with water, they decompose. So they can have a lot of industrial uses. And this is a real thing on Earth. If you look up the town of Boron, named after the element boron, you'll find that they mine lots
helium,
of...
But okay.
Right. You're going to go with helium. Wrong! It's also sort of out in the desert where there are like weird waters burbling up. That's the scientific term is burbling.
Correct.
And they deposit lots of weird minerals and crystals. Now, if you take one of those really cool weird crystals and you wash it in water under the sink, it will dissolve in your hands. You have to wash it in brine that's hypersaturated with the same stuff it's made of to keep it stable. Grind it up into a powder or whatever, and it's got lots of cool industrial uses. But you can't just rinse it, turns out. And so that idea of having something that is not necessarily stable is fairly common on Earth as well. Kind of keep it in its original conditions, get the mud off, and then use it. But you can't wash it like you think in terms of mining gold, and you just run it with water and it's totally stable, and you just need to get the particles out and you're good. That's a completely different scenario than something that will dissolve and never be itself again if you try to reprecipitate it in your water. So I tend to think in geologic time, which is a problem for when I have an appointment on like a Tuesday when you're thinking of millions of years of scales. But if you have minerals that are created under high pressure, high temperature scenarios, for example, and then you put them on the surface of the Earth where it's low pressure and low temperature, they tend to decay, right? Minerals tend to be stable in where they're formed and the conditions they're formed in. That makes sense. So yeah, an unstable mineral like actually completely makes sense. And in those cases, if you disrupt the supply of it, if you think of something that you can mine, not necessarily that it's particularly rare, particularly hard to find, but it's a little bit more difficult to transport and preserve, then the stability causes the rarity. And so if you're disrupting the supply, then you could lose it to get it to where it needs to go to be used, for example. Like you can only keep it stable for so long, or you don't have enough, whatever medium you need to transport it in to keep it cool, or cool or hot or dissolved or whatever, then you need to pay attention to those parameters. You have like, I don't know, a giant star battle going on, then you may not necessarily have a steady supply that's consistent that you can use to manufacture starships.
So finally, we couldn't talk about our, Star Wars geologic properties without talking about spice mines of Kessel or any sort of spice within Star Wars. Mm-hmm. Is there anything that is equivalent to spice in our world today, or anything that's kind of close? The idea that something that becomes, some sort of mineral and it turns into drugs or things like that.
Mm-hmm. Now, this is not my field of expertise, as I don't do so many drugs except this wine I'm drinking now. Yeah. So on Earth, the things that we use as drugs, recreationally and otherwise, tend to be organic compounds that come from plants and stuff like that. However, there are certain parallels. We talked this a bit earlier about outside the podcast. One of the things that immediately sprang to mind is the legends of the ancient oracles in Greece. So everybody thinks about the oracle at Delphi, and there were other ones. One of the things that they think happened with these folks is they would, recruit young women, wink, but they would have like a chair that they would set in these sacred places. And why were these places sacred? Volcanic vents. So these volcanic vents would have all of these gases coming out, and they would put the chair that the oracle would come out when she was paid to give whatever prediction, and she would sit in this chair over the gases, and the god would speak through her. Well, there's a whole bunch of weird gases coming out of the ground from this hydrothermal vent, and she was hallucinating. So you can have a natural earth material off-gassing and causing all sorts of interesting reactions in the human brain.
Or, just depriving you of oxygen.
Hypoxia is a wonderful drug, I hear, until you die.
Aren't they all?
Right. Yeah. Problematic. Catch-22, shall we say. So, in that case, there are, I don't know enough about drugs is a thing I didn't think I would say soon. So I'm like, I kind of want to go and do some research, but there are certainly inorganic compounds that will cause you to have reactions, right? There are, within the geologic world.
Right. How many rocks do you have to lick?
All red ones, I learned that.
No, opposite. Don't lick the red means danger. Everything's made of element, right? And organic or inorganic, if we're talking about an extended universe full of different kinds of planets with different kinds of mineralogy and all sorts of things forming, I have no problem with the idea of mining a mineral that is a psychotropic or hallucinogenic or a feel good or whatever.
It's totally chill, bro.
Whoa, like spice, man. So I don't know. There are different science fiction accounts in completely different universes that will have an organic source for something that's distributed across a planet. The prime example being the spice from the Dune universe. There are certainly other examples that I can't come up with right now because you gave me wine. Yeah, you could have something that was organically created on a planet and then distributed by organic or animal elements that you would then need to mine out of the soil it was deposited in. But I kind of like the idea of an actual mineral being used for something like that, or used as a component.
True.
This has been so exciting, and I feel like this is the nerd stuff everybody needs.
It's fun. Like, what's the point of learning all of this scientific stuff if you can't blatantly speculate and create? Imagination is an important part of universes, too.
I agree. And even if you're not canon...
Boom.
It's really cool.
Fun is not the opposite of serious. Fun is the opposite of boring. If you're enthusiastic about it, you can be completely serious about it. I am completely serious about my science. But it's fun!
Yes.
Yeah.
I'm in on that, yeah.
Mm-hmm.
Well, thanks so much, Anne.
Yes.
This has been incredibly, fun.
Fun.
It's been fun.
Thank you so much for having me.
It has not been boring.
And
it's been super serious.
I'm really excited about this. I'm super excited for other people to hear about it because I think that, everyone's really curious about it, even if you're not a scientist. It's fine. Because it's fun. Because you don't have to be a scientist to be interested in science.
Absolutely. You don't have to have a degree to be able to change the world. Find out what's going on around you. Yeah. Look at things and go, that's weird.
This is usually the part where Brian says something weird, and then we say bye. But you can check us out. You can email us if you really liked this stuff, or hit us up on Twitter and tell us how much you liked it, because we totally want to hear how much you like hearing about the geology of Star Wars. So it's hyperspacepodblast@gmail.com or hyperspace_pod on Twitter.
True, those are both accurate.
And if you also are a scientist and you want to talk about all the sciencey stuff, please let us know, because we would love to have you on the show. Anyway, thank you so much, Anne.
You're welcome. This has been a blast.
PodBlast.
See what I
did there?
She used the title.